the first thing you need to realise is you need to find the difference of each term, then find the second difference, and then do a bit of substitution and work out what the quadratic term gives us, right? Now, the general formula of a quadratic sequence is this: an squared plus bn plus c. Now, I don't want to go over the maths watch example again, but I'm going to show you in action. So, can you see that's 9, that's 13, that goes up by 17, and that's 21. Now that's called the first difference. Now we find the second difference, and you can see it's all going up in 4s. And when you have when the first difference is going up in the same number, that's a linear sequence, and you should be very good at that. When there's a second difference, you know it's a quadratic sequence. Now, all you really need to know is, and I like to do it this way, is, and I won't prove this to you because MathsWatch does it for you, but this is the algebraic proof of it. So you don't really need to understand it. You just need to use this formula. And I like this method because if you can remember this, you can do any quadratic sequence really easy. So this 2a relates to this 4. That's all you need to know. Now this 3a plus b relates to this 9, this number 9 right here. And this a plus b plus c relates to this number 10. Now, the algebraic proof of this proves that for all quadratic sequence, this second difference is always going to equal 2a. So, if 2a equals 4, what does a equal? We just divide that by 2, divide that by 2, so a equals 2. That is perfect. Now, so for all quadratic sequences, this 3a plus b is going to equal the first difference and the first number in the first difference. So that is going to be 9. Now we already know a equals 2, so we can substitute this into this formula here. So 3 times 2 is 6, so we get 6 plus b equals 9. Now, without solving this, you can see that very quickly that b equals 3, because 6 plus 3 equals 9. And the last term, a plus b plus c, must equal this number 10. Now, if a equals 2 and b equals 3, so we get 2 plus 3 plus c equals 10. Now you can just do this by inspection and see c equals 5. So c equals 5. Now all quadratic sequences are in this form. So this letter a, b and c, we just need to put it into this formula. So the quadratic sequence is 2n squared plus 3n plus 5. Now how can you check that it's correct? Well, we can use substitution. So let's let n equal 1, and that means that's the first term. So if this makes 10, it works. So 2 times 1 squared plus 3 times 1, that's 3, plus 5. So when n equals 1, the first term does equal 10. Now let's try that for n equals 2. So n equals 2, so that's 2 times 2 squared, which is 4, plus 3 times 2, plus 5. Let's work that out now. 2 times 4 is 8, plus 6, plus 5. That does equal 19, and you can see that's the second term. And that's it, you know we've got it right. So, let's do 2 examples for you. So we're using this an squared plus bn plus c. So remember, what did I say we need to do? Find the first difference. So you can see that goes up by 6, then 10, then 14, then 18. Right, so you can see the first difference is difference. Now you need to check the second difference is the same to ensure that it's a quadratic sequence, and then you can see that that's perfect. That goes up by 4 each time. Yeah, can you see that goes up by 4 each time? Perfect. So what did I say? So remember, the 2a now equals the 4 for all quadratic sequences. Now this number 6 is always going to be equal to 3a plus b, and this term is going to equal a plus b plus c. Now MathsWatch shows you the algebraic proof of this, so you don't need to, I don't want to explain it again. And this will be my go-to move for all quadratic sequences. This is like a grade 7, 8 old A star topic, but you can use this method, you can answer any quadratic sequence ever asked, essentially. So we've got 2a equals 4. That's quite straightforward, so we know a equals 2. That's step 1. 3a plus b equals 6. So we know a equals 2, but I'm going to write 3a plus b equals 6 here. We know a equals 2, so 3 times 2 is 6. 6 plus b equals 6. Well, b has to be 0. So we've got b equals 0. Now a plus b plus c equals 2. So we know a equals 2 plus b, which is 0, plus c equals 2. Well, looking at this, c has to equal 0. So we sub this into this formula here. So a equals 2 to n squared, that's it. B is 0, so 0 times n is 0, so we don't need to put that in. And c is 0, so that is the quadratic sequence done. Now let's check. Let's just check the third term. 3 squared, so if n equals 3, this becomes 2 times 3 squared, which is 9, and that does equal 18, and that's the third term. So that works. That's correct. So let's try this one now. That's going up by 3, then 5, then 7. Let's just stop there. And we can see that is going up by plus 2. So let's just remember 2a equals 2. 3a plus b, which is going to equal this term here, equals 3, and a plus b plus c is going to equal this term here, 4. So that's nice and easy. We know a has to equal 1 here. Perfect. So 3 times 1 is 3, plus b equals 3. Well, we know b equals 0 here. Now we've got the last one, a plus b plus c equals 4. So we can write 1. We know b equals 0. And plus c equals 4. And you can see c equals 3 here. Sub that into the formula for quadratic sequence. And a equals 1. So 1n squared is the same as n squared. There's no b, so we leave that because b equals 0. And c equals 3. That's the 2 questions in MathsWatch done. So let's recap and see if you can give these 2 a go yourselves. Pause the video and then I'm going to go through them now. So let's see, that goes up by 5. That's going up in plus 9. That's 13, and I can stop there because I can see that that's got up in 4s and 4s. So remember, 2a is going to equal this 4. 3a plus b is going to equal 5, and a plus b plus c equals 4. So let's solve this here. We've got 2a equals 4, divide both sides by 2, we know a equals 2, that's perfect. 3 times 2 is 6, so 6 plus b must equal 5. So this b has to equal minus 1 for that to work. Now we've got 2 now, minus 1 plus c equals 4. So here you can see c must equal 3. Now we sub that into the formula and you'll get that answer. Now I'm going to write the formula again for you. It's an squared plus bn plus c. Now I'm going to do this very quickly. So that's 11. That's 17. That's 23. Let's see. So this is the key numbers that we're only concerned about really. Let's just check the second difference is correct, so we know that's correct, so that we know that this is a quadratic sequence. Perfect, this is done. So we know 2a equals this first term here, 3a plus b equals the first number of the first difference, and a plus b plus c is going to equal 4, the first term. So we just solved that. So we know 2a equals 6. Don't need to do that much solving. You know a equals 3 straight away. So we've got, now we do the second line. What's 3 times 3? So we sub the a in here. We've got 9 plus b equals 11. So b equals 2. As you can see that through inspection, right? So we've got a is 3, b equals 2. So we've got 3 plus 2 plus c equals 4. Well, we know that equals 5. To get this both sides equal 4, c must equal minus 1. So we sub this into an squared plus bn plus c. So we must get 3n squared plus 2n minus 1. And that's the right answer. And obviously if you do this on a piece of paper, like this old A star topic, you can do within 30 seconds quite easily, and that is correct. So, and this green question here is generally the more harder type quadratic sequences that you would find, and I generally believe this is the best method. So there's try as many as you want, but if you can do all of these, all you need to remember is an squared plus bn plus c. You need to find what, 2a, 3a plus b, and a plus b plus c. The second difference is 2, so 2a is just going to equal that 2, and you solve all of that and you're done. So pause the video, give this a go, and I'm going to show you the answers now. Essentially, you can just use some grade 2 and grade 3 skills, and then you can get all this all correct at a grade 7 level, old A star topic level, just using grade 2 and grade 3 skills and a little bit of memory, because this works because it's algebraic proof of it, and you don't need to understand the proof, you just need to be able to do the method and you are done. Hope that helps you a lot.